Good morning. This is Gregg Lippa with Themis Education, and we're here today to get an understanding of Java Batch and the WebSphere Compute Grid capabilities, which are an option for working with Java Batch. So good morning, everyone. My name is Greg. The information at the bottom of the screen lets you know how to reach me, how to get to our website, and also how to get to the page on our website where you can download the slides that we're using today. So www.themisinc.com/webinars is the way to get those slides. There's a download link available to you now. These are the things that we're going to take a look at today in today's webinar. One, why would you ever do this? You've already got batch jobs running in ZOS. Why do you want to switch to Java? What alternatives are? There's a number of alternatives, and we'll look at the advantages and disadvantages of several of them before we move on to talking about WebSphere Extended Deployment XD Compute Grid and what its capabilities are. It incorporates a new feature beyond the standard containers called a batch container. In addition to the web and EJB container, it's a new container that's for running batch jobs and controlling them. We'll look at what components come into play in using Compute Grid, a brief look at some design patterns that relate to modern batch jobs, and the all-important role of JZOS, Java for ZOS, as the role it plays in Compute Grid, as well as briefly other roles that it plays. Got a lot of information to cover. I plan to spend about 45 minutes in the webinar. There is a place for you to ask questions, type in questions in the GoToWebinar, but at the end I can open it up for a few questions. I'd like to make sure we have time to get through the basics of the webinar before we move on to questions. So feel free to send me your questions at glippa@themisinc.com. So we all have legacy systems running on IBM mainframe technology. And as you know, over time, those need to be maintained. But in addition, they might need to be modernized and ultimately replaced. So what happens is, as the requirements for distributed access and other needs arise, we find that maintenance becomes more and more difficult to continue to work with. There are ways of doing wrapping layers like screen scrapers that keep the mainframe systems largely intact and provide that information into more of a web-based interface or some other non-green screen interface. This protects the existing applications that you have and is certainly less risky than replacing the systems, but it doesn't really modernize the underlying applications and doesn't provide a well-maintainable solution. So in the last phase, the replacement phase, we begin by reminding you that this is a risky phase, that, you know, taking something that has been working for years or decades and replacing it with something completely different is potentially going to add to your burden of issues and problems in the system. So it's certainly not something we want to take lightly, but ultimately it becomes something that's necessary to keep up with changing requirements and competitive needs and advantages that are provided. So new systems that might access existing resources on ZOS can certainly benefit from Java Batch, as well as using the opportunity to modernize legacy systems and replace them with Java batch applications. Why would you want to replace your systems? Well, what most people are noticing is that COBOL programmers are beginning to retire. They've been retiring for a while, and there are fewer and fewer schools that supply new blood into the COBOL development world, and more Java developers all the time. You know, it's been a growth area for development. Also, other systems, we have the capability to use Eclipse-based integrated development environments, whether that's Rational Application Developer from IBM or Eclipse itself. Many APIs that are available for getting at the database and message queues and working with XML and web services are part of the Java space. So there are a lot of options there. Performance, there's some benefits that can be had on the performance front with Java. Java performance is a focus of improvement by IBM and others. Of course, there's portability. Java has the ability to run not just on ZOS, but on virtually any operating environment. And there is a factor of cost as well. The zip processors that have the ability to reduce your costs are available to run Java code, and a lot of people look to Java as a cost reduction mechanism as well. In terms of Java standalone applications, when you have large volumes of data that need to be processed on the mainframe, flat files, VSAM, DB2 type data, when you have message queues being used, JMS, Java Messaging Service, gives you the capability to work with message queues and integrate with other types of programming environments and applications written in other languages. The capability to generate printed reports using terminal servers or HTTP servers is also supported. Of course, a batch application implies that there is no user waiting for a response. So the start and stop times are not measured in seconds, but often take hours to execute. Typically, there's a large workload with loops of processing that might go millions of times, and we measure efficiency in throughput rather than response time. So the kind of workload management, WLM type techniques that IBM provides are available for the batch environment as well as for the new Java batch environment as well as the existing. Here's a little flow chart that mainly is intended to point out a few things. One, that both COBOL programs and Java programs can coexist in a job stream. So there are mechanisms here that show return codes determining how to proceed through the job flow, but that the JCL can run COBOL and Java concurrently, not concurrently, but sequentially in the same job stream. So that is an important benefit that indicates that you don't have to decide to switch your whole application over to Java. You can continue with some legacy code still in COBOL and others, other portions of the applications moving to Java. The runtime environment for a Java ZOS batch program is that you would have your compiled Java probably in a jar file. You would have JCL that kicks off the job execution as a batch job. And IBM provides several mechanisms for running standard batch jobs. You notice BPXBATCH, BPXBATSL, and JZOS are all listed there. None of those is Compute Grid. So I want to point out that it is not the only way to run Java batch jobs. Compute Grid is not the only way. There are previous ways that IBM has made available, and a number of our customers have taken advantage of. Some to a large extent, but the execution of Java batch through the mechanisms that are listed here, with BPXBATCH, BPXBATSL, and JZOS, do have some limitations. We'll talk about what those are and how Compute Grid can help you to address those. Again, as the flowchart showed on the previous page, the integration of legacy and modern applications in a single JCL stream and the execution through JCL of Java as well as COBOL is supported by IBM frameworks. All right, so you can, this presentation doesn't go deeply into the fact that Java, when it runs on ZOS, requires a Unix System Services setup. USS is a Unix environment within the ZOS environment. And Java requires that, so you can actually kick off your batch Java processing with Unix shell scripts on that side. This recommendation from IBM is to use JCL so that you have the same kind of JES capabilities and job scheduling, batch security, the capability of organizing your job flow to incorporate other types of processing that are not Java, such as COBOL or REX or other types. The ability to guarantee resources through Workload Manager, and to direct your output to the spool for further handling, printing, archiving, whatever it is you need to do. So this page is largely, we're leading into Compute Grid, and we'll get there in a minute, but this is talking about how important it is to be aware of how Java can interact with standard JCL. Here the three are listed out again. BPXBATCH has some serious limitations, particularly inability to access I/O through DDs. So BPXBATSL is an alternative to that addresses those limitations and does give you access to inputs and outputs through your DD cards in JCL. And then JZOS also provides a runtime environment. You want to kind of keep in mind that JZOS supplies two functionalities. One is this ability to be a job runner of Java batch, and the other is a capability to interact with mainframe file systems and data sets. And we'll look at that in more detail at the end after we've spent some time talking about Compute Grid. So in the little diagram, you see that USS is mentioned at the top, and that the JZOS address space includes not only the Java runnable files, the class files, but also the JVM and the batch launcher that can be kicked off with JCL and support JES output. So USS is, again, part of the ZOS environment, and that's where JZOS and Java batch will run, if that's what you're using. All right, the problem is, or one of the problems is that we have a lot of COBOL, maybe some PL1 logic that's being used to process, our big inputs and outputs that we've been doing over the years and decades. Now with Java capability to run on ZOS, we have to consider some of the issues. One, the JVM is created for every batch job. So this requires some overhead, CPU, and resource consumption, generally greater overall cost. The management of the JCL through Workload Scheduler can help with that, but it is still a risk and a limitation. With traditional WebSphere application server containers, also known as WAS, WebSphere Application Server, traditional WAS containers allow for the ability to run distributed web-based applications. But with the introduction of Compute Grid, now an additional container called the batch container extends these WebSphere core functions, making them available to a batch processing environment. With Compute Grid, you have a number of advantages. The Java batch can run concurrently with your online transaction processing workloads. That may or may not be ideal for your environment, but it is supported. Also, you have management capabilities, versioning support that can help to reduce the cost and complexity of managing your various WebSphere resources, Java and other types of resources. So this means that WebSphere can become the focus for configuration and help to increase your adaptability as business needs change. By having those components in WebSphere, you can take advantage of the support that WebSphere provides for using those components in both the batch and online environments. You also have the capability to scale up for higher volumes when needed by introducing additional servers, WebSphere servers, into your cluster. And of course, as we've said, the Java skills and many resources that are now available to Java developers working on batch compute grid-based applications. Now, many of you know that WebSphere is IBM's implementation of Java Enterprise Edition. It has been a real centerpiece of distributed applications for many years in IBM since nearly the turn of the century, and is a very popular environment for our business applications today. So there's a large and rapidly expanding skill base among developers, which can play into reducing development costs and even development time, because of course Java is an object-oriented environment, and this has benefits, has payoffs. Java applications and frameworks are widely available. There are many applications that have been developed, and many frameworks, often free frameworks like Spring, Hibernate, many others, MyBetas, that have the capability to further reduce development times and increase cost savings. So in the traditional environment, you have an OLTP workload where your clients may be web clients, other types of clients like EJB clients, messages coming in from a message queue, or web service requests. These are typically relatively short-hitting, transaction-oriented with the business logic written in Java. And WebSphere has been managing this kind of transaction processing for a very long time. Requests coming in from the client into the Java EE application, and the business logic running inside of WebSphere, most likely accessing some kind of database information, and then returning back to the client who made the request. WebSphere supports a number of very useful container services. We've listed a few of them here. The ability to manage security, declarative transaction support, web service support, sessions for remembering information for periods of time, pooling to improve the performance of database connections and other things, caching, support for messaging. So a massive environment that WebSphere supports, provides to support your Java development. Among the benefits that these container services provide are better security, availability, performance, simplifying design development of applications, speeding up development time. But from traditional batch and the approaches that we'd already talked about, BATSL, BPXBATSL, and JZOS, your WebSphere-based logic is unavailable. That logic that is deployed, I mean, you can manually try to make it available, but it's not automatically available as it is with a WebSphere-based application. So with WebSphere Compute Grid, your batch workloads, as we said, run concurrently with each other as well as with OLTP, if that makes sense for you. And the batch container gives you a way to integrate traditional batch execution as well as sharing your Java resources across both batch and OLTP, online applications. The batch workloads traditionally run in a separate environment that has to be isolated somehow or run in the batch window at night, often causing duplication of resources and limiting the ability to share those resources. So by using Java Enterprise Edition servers like WebSphere to support your existing batch programs, as well as those that are being added or maintained as now Java applications, is potentially a major benefit. Here we contrast the traditional batch and OLTP workloads. On the top half, we see JCL being used through the job entry subsystem to access resources through IMS CICS or standard COBOL processing. And then at the bottom, we talked about the various clients that might be using, web clients, web services, message queues, and so on, kinds of clients that would be accessing Java workloads through WebSphere. So we have the kind of the mainframe traditional environment on the top, the WebSphere environment on the bottom, the backend DB2 throughout. With the advent of Compute Grid, now we see on the JCL approach, we have this new arrow that gets us down to running Java within the WebSphere Compute Grid environment. And still, of course, having access to DB2, wherever it is, ZOS or otherwise. At the same time, the existing clients that were already using WebSphere and Java are still available, still have that available to them. So drilling down a little bit now into Compute Grid, what you get with Compute Grid is both a job scheduler and an execution environment. There are also some features for long-running batch applications such as checkpoint restart support. We'll take a brief look at that. So the OLTP online type applications that we traditionally support through WebSphere still supported, but with the extended Compute Grid capabilities, we now have a batch environment that is making use of systems similar to the job entry subsystem, job control language, job dispatch, and then job executors in WebSphere. So what we see now is that in addition to the traditional clients we've talked about, we now have an external scheduler. And within WebSphere, we have a batch capability. So the same business logic that might have been applied over the years to these kinds of client requests coming in through an online distributed type system are still available. And using Java database connectivity to get to DB2, using other Java connector capabilities to get to CICS or other resources are supported. So we have the ability for WebSphere-based applications to be able to interact with mainframe resources. These Compute Grid applications are made up of Java Enterprise Edition applications. IBM has incorporated XJCL, which is an XML-based approach to job control language. They have incorporated a job scheduler as well as the batch container, which is made up of grid execution endpoints, where those Java jobs can run and can be split into parallel jobs. There is automation along those lines. A parallel job manager detects and implements mechanisms to parallelize jobs in ways that it can configure as such. So instead of a single JVM, a clustered environment can be used, and that can increase those capabilities for scalability and parallelism. Now, JZOS was mentioned briefly earlier as a way to schedule and execute batch jobs. And that's what's shown over here, this ability coming through the job entry subsystem. But there are also APIs that are provided by IBM in the JZOS environment to support the ZFile system and VSAM, as well as the hierarchical file system that is operating in the Unix system services. It seems less likely that you would have your production files on the hierarchical file system on the Unix side, but JZOS has APIs for getting to those as well. Importantly, though, the ZFS, the ZFile system for getting it, PDS, sequential data sets, and as well as VSAM. So JZOS has a couple of roles, and one is really not related to Compute Grid, and the other is more related. All right, so again, the JZOS launcher and the JZOS APIs are both part of the JZOS environment. But as far as the role in Compute Grid, it's the JZOS APIs that allow Java to talk to mainframe resources. On the launcher side, these capabilities are lacking from all the technologies that preceded the Compute Grid offering from IBM. Security, transaction, connection, facilities, checkpoint restart, high availability that WAS provides, all of that, persistent reusable JVM, as we mentioned earlier, are capabilities that the JZOS launcher does not supply, that Compute Grid does to provide the kinds of quality of service needs that modern enterprise applications require. Now, the basic flow of a batch application is that there are inputs and there are outputs, and if it's a Java batch application, there are probably objects that relate to those inputs and outputs. So the ability to map that input data, however you're getting it, to Java objects, and then conversely map the output back from the Java objects is one of the basic needs, probably the primary need of any batch application. So we'll take a look at how Compute Grid addresses those needs over the next few slides. Again, Compute Grid's primary capability is the batch container. This is an extension of the standard WebSphere application server, going beyond the standard enterprise edition requirements for a web and EJB containers. And this container controls a set of plain old Java objects. They're not tied into any framework, and uses those to control and run the batch job throughout its entire life cycle. So the batch components that you would need are a job step that is executed by the batch container, and probably one or more data streams that allow you to do your input and output as necessary, whether that's a database or whether it comes from the file system, message queues, or other types of data through Java connector APIs. This slide gives you a sense that checkpoint and result algorithms are often part of the picture. Checkpointing gives you restartability without having to rerun the whole job, and the result algorithm allows you to specify an overall return code for the job based on the success or otherwise of the steps contained in that job. Also note here we have listed the batch data stream. That's the capability that allows for access to files, relational databases on DB2 or any database. The bottom area is pointing out that DB2 is also used to support the batch container and manage the flow of the job and the restart capabilities as well. So the batch container responsibility includes the requirement to open and close batch data streams, and also handle the checkpoint related callbacks to ensure that a reasonable amount of work is completed in between commits on a job. So while it's optional, it's certainly going to be beneficial in many cases to utilize the checkpoint capabilities and result return code capabilities that are provided as part of the Compute Grid environment. Again, checkpointing means being able to restart a job from some point of consistency, and possibly even having planned outages be supported as well. So Compute Grid provides both a time-based and an interval-based record count-based checkpoint capability. So you can say we're going to checkpoint every 10 minutes or every 1,000 records, or whatever makes sense. And those are built in and configurable through the Compute Grid tools. Similarly, the return code from all the steps in the batch job are used to generate an overall return code, and there's a mechanism built into Compute Grid to support that as well. We see the overall structure of a job lifecycle beginning on the upper right where it gets submitted, and hopefully completing here, or possibly you see many roads leading into the restartable category. If there's, well, certainly the potential for failure, possibility that the job gets canceled or suspended for some reason, all of those leading to some kind of restartable state that can then be used to support resubmission of the job. In terms of making use of batch application capabilities, there are a couple of patterns that are recommended in IBM's documentation, including a generic batch step pattern, one input, one output, and an error-tolerant batch step that has an additional output for an error stream as well as the input and output streams. Also, patterns for checkpointing are mentioned here. Again, records-based checkpoint when a certain number of error records have been processed, or percentage-based, based on the ratio of the number of error records to the total number of records processed, to force a job to go into restart when too many errors have occurred. In terms of a few details about Compute Grid, the required interfaces allow support for the job step and the data stream. The optional interfaces allow support for a checkpoint policy and a result overall return code for the job. In terms of deployment, it's standard ear deployment as we have to WebSphere in any Java Enterprise Edition application. And that would include your batch POJO, that is, again, a plain old Java object that carries out the business logic that's required by the application, and communicating with other Java components as well. In terms of the WebSphere Compute Grid environment, there is the batch container. There's also a framework for EJB, for batch using EJB, and a controller for the job itself. But those are supplied by the framework. Your job is to build the business logic to run your own application. All right. In terms of a unit test environment, there is a capability built in to do batch simulation in Eclipse with a standalone WebSphere application server instance. So you can do your initial testing in a local environment before deploying to your development and other dev and other test type environments. Now, on the MVS side, your enterprise data is probably sitting over there in DB2, but you also may have VSAM or other types of files that you want to connect to. The same kinds of database connectivity we use with Java in any application can be used with the batch application, but remembering that these applications in a Unix environment need access to MVS data sets. This is where the JZOS Toolkit library gives you some additional capabilities, supporting mainframe file systems, which are not available through the java.io package and classes that are supplied there. So JZOS provides all kinds of capabilities for accessing MVS data sets of all types: sequential, PDS, VSAM, KSDS, as well as other types of VSAM files. We'll take a brief look at that. The central component or class of the JZOS approach is called ZFile, and when you construct it, you give it a file name, which could be a DD name, and a mode of how you're going to access it. So in this example, we have a DD name called myDD and a mode of read. In the second example, we have a file PDS sys1.help containing a file called account, and we have a mode of reading that as a text file. And in the third example, we have a simple file name, and this is supporting writing that as binary data and providing a format and an LRECL. So just some examples of how you would initialize communication with these kinds of files, and a couple of methods that you might use against the objects that are returned and referenced by these variables. So a few other capabilities of the JZOS to work with VSAM. So we've laid out a brief introduction to VSAM data sets and the fact that they include logical records and clusters, and that IDCAMS is the utility program that allows you to allocate those data sets. JZOS is not about allocating, but more about using those VSAM data sets. So here we have just a little bit of information about some of the methods that you could use to instantiate a ZFile object that can interact with VSAM, locate a record with a particular key, and then read that record into a buffer. So certainly much more capabilities are supported in terms of the batch application programming courses that are provided by Themis. We get into those kind of details. Again, the slides are available from our website, and the other courses that will support batch Java and other Java capabilities will be available and found on our website. I'll give you that address, themisinc.com, and we'll see it on the closing slide as well. Just a few other methods, just the ability to locate, read, update, write, delete. You have all the kind of VSAM capabilities that you would expect using the ZFile and JZOS capabilities. One other thing I want to mention before we wrap this up is the existence of COBOL copybooks and how widely they are used to map record formats into COBOL applications, COBOL-based applications. Converting from some of these mainframe types to Java types can be quite painful. It can be done manually, but it is difficult. And this slide mentions that Java record classes can be built programmatically from a copybook. There is an automated process and development time tools that will create Java classes that more or less map to, or that do map to, the input or output file record structures that are so widely used in a COBOL-based environment. So there's a tool to automate the conversion of the record types, the data types in those records for Java usage. So overall, our intent here was to give you an overview of batch programming, especially in Compute Grid, and talk about its benefits in job scheduling, providing checkpoint restart, supporting parallel processing, integrating with legacy applications, and utilizing the JEE resources that we already have built to support our online types of processing. Variety of Eclipse-based tools that will assist in this type of development, targeting batch jobs running in Compute Grid. Again, this is our website. The link points to the Java category where we have dozens of courses available to support your Java programming needs, including working with the Java batch environment. So I would like to thank you for coming and welcome you to check out our website, download the slides if you're interested, and also the ability to replay this webinar at a future point if you'd like to, or if you'd like to offer it up to colleagues who could not attend today. Again, this has been Gregg Lippa for Themis.